Hope everybody's doing well. Hope everybody's staying safe, and hope all your family is doing well too. So this is where I'm going to be doing most of the work, at least for now. There are other options I'm just trying to decide between of the best way to present information to you, and any information, constructive criticisms you can give me. Just let me know that too. A lot of this is trial by fire right now with everything going on. So uh, first thing up is I'm going to do a review for exam 2, and I've been thinking about how to administer the exam, and it's probably going to be through it's going to be online of some sort, obviously, and it's probably be multiple choice, maybe some open-ended questions. We'll see. And what I would like to do is to have that exam open up at let's say about 7 or 7:30, and then I'll give you till 8:15 or 8:45, roughly an hour to hour and a half, depending on how long I make the exam. So it will have to be timed, and it will shut off you'll have to start at a certain time and finish by a certain time. So I will send an email out with more details of that. I just want you to be aware and looking for that. Once again, please just be patient with me while I'm learning the best way to get this info to you. Okay, so to start the review, I'm going to look at Lab Module 3. This is the last lab I gave you that I said I was going to take up after spring break. I'm not going to take this lab up, and I'm still debating about what to do with the other labs for the rest of the class. But we're going to use this lab as the review for exam 2. So let's start with number 1. A ball is thrown vertically upward from the top of a building 160 feet tall with an initial velocity of 48 feet per second. The distance d of the ball from the ground after t seconds is d of t equals 160 plus 48t minus 16t squared. So there's a bunch of mumbo jumbo in this problem. What you need, and we're only going to look at part B in this example. Part A is I'm not going to test you over. Part B is what we're concerned about. But what you need to weed through here is you need to recognize that we're dealing with a quadratic, something of the form ax squared plus bx plus c, and it's giving you a formula. So we're on 1b, and part B says, when will the ball reach its maximum height? What is the maximum height of the ball? So what this is essentially asking us is to find the vertex of d of t. And I'll go ahead and write d of t up here. I didn't give myself enough room. I would suggest that you take notes just the same as we did in class. Try not to treat anything I'm doing differently. And please let me know if I'm not being detailed enough or being too slow or being too fast is probably what I'll end up doing. But you can pause the videos, so please keep that in mind. Here's d of t. So what this is asking us is to find the vertex. To find the vertex of something of this form, this is the formula. Vertex is equal to negative b over 2a, comma, f of negative b over 2a. In this case, I wrote f, but we're dealing with b. Just as long as you know this means to plug it back into whatever formula you're using. So we need to start off by finding the x-coordinate, the negative b over 2a. So negative b over 2a. Can you see that? Yeah, it looks like it. So what I like to do is take your time. You know this negative sign is part of the equation, and so is this divide sign. Just go ahead and write those in. And b is this term here, so 48. And then 2 times a is negative 16. You can't forget the negative there. That is negative 48 all over negative 32. And if you reduce that, the negatives will cancel out. And then 48 and 32 have a 16 in common. So 16 goes into 48 3 times, and 16 goes into 32 twice. So I know I did that a little fast. Go ahead and pause it and work through that just to make sure you can get the same answer. So that is the x part of our vertex. But I'm going to write the answer. The answer is going to be up here. Vertex. So I just found the negative b over 2a portion. Let's just rewrite it here, the formula. And so the x-coordinate I just found to be 3/2. And now I still need to find f of negative b over 2a. And sorry about the lighting issue there. Just bear with me, and if you have comments about the sound or video or anything, just let me know, and there's a couple apps I might try. Just give me feedback, anything constructive, and I'll look into it. So in this 3/2, I can replace this negative b over 2a portion here. So I'll go ahead and do that. That's f of 3/2. So now I need to figure out what this f of 3/2 is going to be. And we'll do that here. F of 3/2. That means I plug 3/2 into the function. Well, I'm actually using a d here. So let's just replace that with a d. There's no issues if you use the wrong letter. You can just go back and fix it. Especially with this type of problem. Now, if there's a bunch of functions with a bunch of different letters, you want to make sure to be very consistent there. So d of 3/2 means I plug into this equation everywhere there's a t. So I plug in 3/2 here is equal to 160 plus 48 times t, which is 3/2, minus 16t squared, and that t is 3/2 now. 160 plus 48 times 3/2 and minus 16 3/2 squared. And I didn't do a very good job of squeezing that in. But this says minus 16 3/2 squared. This is equal to 160 plus 72 minus 36, which is 196. So that is my y value for the vertex. So the vertex now is 3/2, 196. Alright. Again, leave comments in the review or in the the comment section below, and I will answer your comments with another video. And alright, so if you recall, there's another vertex formula we have to worry about. We'll call this number 2. This isn't part of the lab, but I'm going to call it number 2 anyways. Find the vertex. And here's part A. Use a different color. I have some of this. F of x is equal to negative 2x minus 3 squared plus 5. So, to find the vertex of something like this is different than what we just did. It's faster. You just have to be careful with signs and know what you're looking for. So the vertex here is h comma k. This h portion, or the x value, comes from inside the parentheses, and it's by taking the opposite of the sign inside. So this is a negative 3. That means the x value here is a positive 3. And then for the k or the y value, you take the same sign as on the outside, and that gives you your values there. Alright, I'm going to stop with one example there. Hopefully you're okay with that, and if not, again, you can leave comments, you can look it up, other videos online also. You just let me know what you need, and I'll continue to adapt how I'm presenting this, because I know it may not be the best way right now. Alright, now I'm back to the lab on number 3. And let's do part A. So for this function f of x that they've given us, part A says find f of 10 using synthetic division. So here's part A. Find f of 10 using synthetic division. So notice it says f of 10. That's telling you that our x value is 10, and that's also the number that we want to plug into our box. If you go back into the notes for this section, I believe I went over one of these. It's been several weeks now, so, but if not, we're going to look at it again now. So we put 10 in the box, and then what are these values? How do these get populated? They are the coefficients of each of the terms in the function that we're using. 1 x cubed minus 7x squared, so that's minus 7, plus 8x plus 16, so 8 and 16. That is not giving me enough room. So you start, let's use a different color for this. Start by bringing down the first number, which is a 1. 1 times 10 is 10, and you always add down to give you 3. 3 times 10 is 30. Add down, gives you 38. 38 times 10 is 380. Always add down, 396. So what are we looking for when we're using synthetic division? We want to know what this number is here, and that is the remainder. The remainder of 396 doesn't tell us a whole lot here, but it does tell us, since the remainder is not 0, that tells us that 10 is not a 0 also, and we'll get to that more here in a second. But this fulfills what A was asking us. It was asking, what is f of 10? By plugging in that value into the box, running through synthetic division, the remainder gives you your answer of f of 10. For example, if I wanted to know what f of 10 was, then I just plug 10 into the function that it gives me. That f of x, that x cubed minus 7x squared plus 8x plus 16. So I get 10 cubed minus 7 times 10 squared plus 8 times 10 plus 16. And if I run through the addition and subtraction, it will equal the 396. So in some cases, running through synthetic division may be a little simpler than actually plugging in. But the key thing here is to realize that plugging in your value into the box gives you the same answer as plugging it into the function. Alright, let's move on. I'm going to skip part B. Well, actually, I did part B already. I told you, since the remainder wasn't 0, that this isn't a 0. And now we're going to go to part C. C says, use synthetic division to determine if x plus 1 is a factor of f of x. So the question here is, what do we plug in the box? And go back and look at your notes and of this section and read through it. And I'll send a review out also for you to study. But use all these resources that you have available. So first we need to figure out what we're plugging in the box. So we have to use this x plus 1. What we do is we take x plus 1 and we set it equal to 0. And we solve for it. So you get x is equal to negative 1. Negative 1 is what we plug into the box. So then it's the same setup. Negative 1, and then all the coefficients are still the same because we're working with the same problem. 1, negative 7, 8, and 16. And now it just works the same. You start by bringing down the 1. 1 times negative 1 is negative 1. Always add down. You get negative 8. Negative 8 times negative 1 is 8. And add down, which is 16. 16 times negative 1 is negative 16. Always add down, which is 0. That is what we're looking for when we're trying to find zeros of a polynomial function using synthetic division. We want that remainder to be 0. And that tells us what? That tells us that the number we used in the box is a 0 to the function. It's one of the zeros. Now we still have to continue on and find the other zeros, which that is what this part E is talking about. It says list all the zeros and their multiplicities of the polynomial. So to keep going here, we can turn this into another function that we need. So this is the remainder. So always start to the right. This is the remainder, constant, x, and x squared. And from this, we get, these are now the coefficients of each of these. So you get x squared minus 8x plus 16. And now we want to set this equal to 0 and solve for x. And my video got messed up. So I'm going to rewrite that up here. X squared minus 8x plus 16 is equal to 0. And then using AC method, I'm going to assume we're all still okay with using the AC method, and I'm just going to write the answers. So that's x minus 4 times x minus 4 is equal to 0. And so we have two x minus 4s, we can combine them. So when you have, so you would get x minus 4 squared is equal to 0. And then now we need to solve and get x by itself. Since we have a squared, to get rid of that, we square root both sides. So by square rooting both sides, we do this and this. So you get x minus 4 is equal to 0. Add 4 over, so you get x is equal to 4. So now we have part E, says list all the zeros and find their multiplicities. So we found all the zeros. One of the zeros is x minus 1. I'll go ahead and write that here. That's the easy one to forget. So please make sure to remember, always go back and remember the first 0 you plugged into synthetic division. And the second 0 was x equals 4. So to find the multiplicity of these two zeros, what do we have to do? What you have to do is you have to go back and see where this x minus 1 originated from. And you have to go back and see where this x equals 4 originated from. So this x equals 4 originated from this x minus 4 squared is equal to 0. So the way you tell if it's even or odd multiplicity is by that exponent, which is a squared. So even multiplicity, I'm just going to say multi here. That means it touches and turns around at that point. So, and touches and turns around is the same thing as saying tangent. So I'm going to use tangent here, so I just limit my writing. Tangent to x-axis at 4, 0. And then this x minus 1 originated over here at this x plus 1, which it has parentheses, but we don't have to, they're not written there because the exponent is just a 1. And 1 is odd. So odd multiplicity. That means it crosses the x-axis at that point. At -1, 0. And chances are the exam is going to be some type of multiple choice test online. And I'm only going to give you an hour to do it. That's what I've been leaning towards. So prepare for that. I'm going to make the exam start at right at 7. And I'll give you till about 8:15ish. But I'll have the details more ironed out more here in the next few days. But I just want you to prepare for that it's going to be roughly around 7 next Tuesday. And I'm only going to give you about an hour. But there will be more there will be several sections we need to cover next week, so there'll be multiple lectures also. And I'm going to give you a 3-day window, like my email said, from Tuesday to Friday to watch the videos. Okay, let's move on. Alright, so the number 4 on the lab, it says for the function f of x, and I'm not going to read the function, I'll write it here in a second. We're going to look at, state the degree of the polynomial. I'm not going to write that one down. Number 4, f of x equals, oh man, I'm not going to have enough room for this anymore. I need to do for 6x plus 2. Alright, so state part A, state the degree of the polynomial. Hopefully that one's pretty easy. The degree here, which means the highest exponent, n equals 4. Part B says state the number of zeros the polynomial function will have. I'm going to skip that. We might come back to it, but I'm going to do a little bit more here. So the degree is n equals 4. What does that tell us about n behavior? You remember that there's a big chart that we worked on in class. If the degree is even, that means the n's do the same thing. If the degree is odd, which starts with an O, then the n's do opposite. So odd, opposite. Even, do the same. So if the degree is even, think of the x squared function that we always dealt with. So it looked like this when we dealt with the x squared function. Both n's do the same thing, they both go up. But if you had negative x squared, both of the n's go down. So the degree is the same, n's are doing the same here, both go up, n's are doing the same here, they both go down. The only difference is the leading coefficient now. This one's a positive, up, positive means up, negative means down. So, so back over here, we have a 4, which is an even degree. So they both, the n's do the same. So n's do the same. And then you want to look at the leading coefficient, which is 3. That's positive. So that means n's go up. So you have this situation here. So both n's go up. Just real quick, since we looked at the even case, let's look at the odd case real quick. And the one I showed you in class was, and I know I'm being kind of vague with my drawings, but there roughly is the x cubed function, and here is the negative x cubed function. So what to take away from this one is the degree, or n is what we label it as for short notation, is 3, or odd. So if the degree is odd, n's do opposite. Opposite. And then the only difference now, I mean opposite, one goes down, one goes up. Now the only difference between these two is the leading coefficient, the LC. This one's positive, and this one's negative. So for the positive case, it looks like an increasing function. When you read it from left to right, it goes up. So positive LC means it looks like a positive increasing function. So if LC is positive, then you have this case. And if LC is negative, it goes down like a decreasing function. I hope that's clear. Go back in your notes and look that over. And again, this will be in the review too. Okay, so now let's get to part C. Use the rational zero theorem to list all the possible rational zeros. Here I'm going to wish I had longer boards where I turned these the other way. So, possible rational zeros. I abbreviated those as PRZ. PRZ. So we have this big division going on here with a bunch of pluses and minuses, if you recall. On the top are the factors of the constant term. Factors of constant. And the bottom is the factors of the LC, the leading coefficient. Now it's just plug and play here. So the factors of the constant term, well, first let's do this. Just go ahead and draw our line so everything's set up. Factors of the constant here is 2. So what all numbers can multiply to give you 2? All the factors of 2, excuse me. So 1 and 2. Plus or minus 1, comma, plus or minus 2. And then what are the factors of 3? All the things that can multiply to give you 3, basically. So 1 and 3. And now what we do is you take each term in the top and you divide it by each term in the bottom. So we'll start with the plus or minus 1 and we'll divide it by this plus or minus 1, and then we'll take the top and divide it by the plus or minus 3 again. So you get plus or minus 1 over plus or minus 1, and then plus or minus 1 over plus or minus 3. And now we've exhausted all of our options, so now we move to 2. Plus or minus 2 over plus or minus 1. And then plus or minus 2 over plus or minus 3. And then from here, we can just simplify. 1 divided by 1 is 1, so plus or minus 1. And then 1 over 3 is just plus or minus 1 over 3. 2 over 1 is 2. And then 2/3, that stays the same. I forgot a plus or minus there. So this would be your answer for the possible rational zeros. The next thing I want to look at, number 4 doesn't ask this question. Number 5 does, but I'm not going to work number 5 because we're covering all of those same type of questions here. So to add on to part 4, I don't even know if I'm on A, B, C, D, E, F. So the last one's F. I'm just going to say this is H. Find the maximum number of turning points. So to find the maximum number of turning points, you take the degree and you subtract 1 from that number. In other words, the turning points, if I just label the turning points as TP, that equals N, which N is, remember, the degree, minus 1. So for number 4, we already said my degree was 4. So I'll plug that in here. TP is equal to 4 minus 1, which is 3. Next thing we're going to look at are asymptotes, which is kind of what 7 and 8 are doing. I'm just going to look at how to find the asymptotes. So I'm just going to call this number 7. It's not going to follow the number 7 from the lab very well. I'm just going to make up some examples here. Find HA. HA meaning the horizontal asymptotes. And here's part A. F of x is equal to 3x minus 2 divided by 4x plus 5. So I taught you how to do all these problems and get them all right just doing one thing. And that one thing is looking at the degree of the numerator, the top, and the degree of the denominator, the bottom. So if the degree of the top and the degree of the bottom are the same, then what do? You take their coefficients. So in this case, the degree of the numerator is 1, and the degree of the denominator is 1 also. So they're the same. That means we can take their coefficients, and that is our horizontal asymptote. So we can say HA is y equals 3 divided by 4. Now the question is, what do we do if they're not this? If the degree is not the same on the numerator and the denominator? Part B. Let's call this g of x equals 3x squared minus 2 all over 4x plus 5. So the only thing that changed between these two problems is I put an x squared right here. I put a square. So now the degree of the numerator is 2 and the degree of the denominator is 1. So they're not the same. So what does that mean we have to do? That means we have to make them the same. We make them the same by adding in whatever degree we need on the bottom. So we need to add an x squared on the bottom so that it doesn't change the problem. So I do that by making the coefficient 0. 0x squared, just, it doesn't change anything. It's adding a 0 in. So now that they're the same, we can take their coefficients and we get 3 divided by 0. So the HA is y equals 3 over 0. And then the third option for the horizontal asymptote is part C. Let's say we'll call it h of x. And now all I'm going to do is move this squared and take it to the bottom. So let's say I have 3x minus 2, and now I'm going to make this 4x squared plus 5. Just kind of showing you how I'm making up the problems as I go. So the degree of the top is 1. It's 1. The degree of the bottom is 2. So they're not the same. We need to make them the same. How do we make them the same? We add a 0 x squared on the top, or whatever we needed. In this case, 0x squared again. Now we made the numerator and the denominator the same degree, and we take their coefficient 0 divided by 4. So HA is y equals 0 over 4, which is 0. And I realized I need to come back up here because 3 over 0 is undefined. So that means no horizontal asymptote. Alright. Alright, to find, we'll call this number 8, to find the vertical asymptotes, call VA. Find VA, I'll call it VA. Part A. I'm running out of black ink. I wonder if you can see this color. Part A. Find of f of x equals, we can do actually part A from the lab, part 8, number 8 from the lab. 7x squared minus 8x plus 11 all over x minus 6. So to find the vertical asymptote is the same as finding domain of something in this form. That means setting the bottom equal to 0. So x minus 6 is equal to 0. So x is equal to 6. And this is what our vertical asymptote is. It's whatever number gives us 0 in the denominator. This could be a bigger function on the bottom. It could be something where you have to use the quadratic formula or the AC method. So just keep that in mind while you're going through these and looking at the review.